tes, satu dua tes. Ayo, Pilda cepet-cepet.
Hi guys, can you all hear my voice? Good morning everyone. Since it's already 10 past 8, let's begin today's webinar.
Bismillahirrahmanirrahim.
Bismillahirrahmanirrahim.
Assalamualaikum warahmatullahi wabarakatuh.
A very good morning to all of our distinguished participants. I hope you're all as excited as I am because today is packed with energy, inspiration, and endless opportunities. Welcome to the High School Scientific Conference 2026. I'm Dinda and I'm honored to serve as your Master of Ceremony for today's event.
And I'm Paramita on behalf of the organizing committee. It's a pleasure to welcome all of you, our esteemed guests, speakers, teachers, and of course our brilliant students participants to this year's conference.
We sincerely hope you're doing well and feeling as enthusiastic as we are to dive into a day full of exploration and learning. We have an exciting lineup ahead, keynote speakers, sharing sessions, interactive discussions, and more. Whether you're here to present, learn, or simply be inspired, there's something here for everyone. Let's have fun today.
And now we would like to extend our warmest gratitude to the individuals who have made this event possible. The distinguished conference speaker, Mr. Marco Cognita, PhD, and Mr. Nathanai Praninatawi, Master of Science. The Honorable Headmaster of Senior High School Bekasi, Mrs. Dr. Anda Tuhrani Komar, MPD, the Vice Principal of Student Affairs, Mr. Ahmad Fauzi, SPD, our dedicated Language and Literature Club Supervisor, Mrs. Liana Prastilia, SPD, and Mrs. Anisha Damayanti, SPD. The distinguished supervisor of the High School Scientific Conference, Mr. Octaviano Hartanto, SPD, MSc, the heads of Language and Literature Club, Aksi Redaction, Kir and Option, Siti Sadia Nuril Ramadhani, Putri Balkis Nur Fauzia, Audi Beauty Aulia, and Hafiz Ananta Priyambodo, the head of the High School Scientific Conference Committee, Christian Ricardo Pangabian, as well as our esteemed teachers, staff, and participants whom deeply value. Thank you all for being here and contributing to the success of this event.
Next, we will begin our welcoming session. Though our headmaster is unable to deliver her messages live, she have kindly prepared welcoming videos for us.
Let us begin with a message from our headmaster, Mrs. Dr. Anda Turhani Kamar, MPD. Please direct your attention to the screen.
Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone, distinguished guests, our respected speaker, teacher, and all participants of the High School Scientific Conference 2026. It is a great pleasure to welcome all of you to High SSG 2026 with the theme Architecting Future Intelligence. The conference offers agency, AI infrastructure, and scalable ventures. High SSG is available opportunity for high school students from across Indonesia to learn, exchange ideas, and explore to the development of science, technology, and artificial intelligence. Through this conference, I hope all participants will not only gain new knowledge, but also be inspired to think creatively, ask meaningful questions, and develop ideas that can contribute to the future. I would also like to express my sincere appreciation to our distinguished speaker Marco Cogneta PhD and Mr. Nathanael Prenative Magister Science Mr. Job for taking the time to share their knowledge, experience and insight with us today. I hope that all participants will make the most of this opportunity by actively listening, participating in the discussion, and asking questions. My appreciation also goes to the committee members, especially LLC with the support of KIR, AXI, Option, and OSIS for their hard work and their dedication in organizing this event. To all participants, I encourage you to stay serious, be open to new ideas, and enjoy every part of this conference. Remember, innovation often begins with a simple ideas and the courage to turn that idea to action. Finally, I hope that ISSC 2026 will be an inspiring and memorable experience for everyone. May this event encourage you to continue learning, creating, and using science and technology in meaningful ways. Thank you for your participation, and I wish you all a wonderful and inspiring conference. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Now, let us continue with the welcoming from Mrs. Anisya Damayanti SPD, our LLC supervisor. Please give your attention once again. Okay. Assalamualaikum warahmatullahi wabarakatuh. Honorable Principal, Ibu Dr. Dr. Heni Komar, MPD, distinguished speakers, Dr. Marco Cogneta, PhD, and Mr. Nadanai Pranidadavi, MSc. Esteemed colleagues, including the advisor LLC, Ibu Diana Prasilia, SPD, and Mr. Octaviano Hartanto, MPD, and all enthusiastic participants present in this virtual room today. And good morning. It is a distinct honor for me as the advisor LLC to welcome you to the High School Scientific Conference HSSC 2026. We express our deep gratitude to Dr. Cogneta and Mr. Nadanai for honoring us with their expertise today. Your participation elevates academic standard of this event significantly. Our appreciation also goes to the school leadership for their invaluable support, LLC and team, and to my colleagues for this excellent collaboration. To the organizing committee, the students of the LLC and team, I commend your exceptional dedication and hard work in realizing conference. The theme from ideas to implementation with AI and the hands of the next generation is highly relevant. We trust the platform will empower students to harness AI technology creatively and responsibly. I encourage all attendees to engage actively and maximize this learning opportunity. Thank you, good luck, and let us commence for this conference. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, Mrs. Anisha. Unfortunately, our high school scientific conferences supervisor, Mr. Octaviano Hartanto, could not join us on this welcoming session because he's having a praying agenda at this very moment. And last, but certainly not least, we'll hear from the head of High School Scientific Conference 2026, Christian Ricardo Pangabean, who will deliver his opening remarks. Tutian, the screen is yours.
Okay, good morning everyone. Honorable Principal Ibu Dr. Anel Turhani Komar MPD, distinguished speakers Dr. Kognita PhD and Mr. Nathanael Pranete MSc. Respected teacher, advisor, fellow committee members, and all participants of HSSE 2026. As the chairperson of the organizing committee, it is my great pleasure to welcome you all to the High School Scientific Conference 2026. This conference is the result of the handwork, collaboration, and dedication of many people. I would therefore like to express my sincere expression to our school, teachers, advisors, committee members, and everyone who has supported us throughout the preparation of this event. We are especially grateful to our distinguished speakers for taking the time to join us and share their knowledge and experience. To all participants, I hope you will actively engage to go to the conference, exhibition, exchange ideas, and make the most of this opportunity. On behalf of the organizing committee, welcome to High School Scientific Conference 2026. We are truly glad to have you with us today. Thank you, and I hope you have an inspiring and enjoyable conference.
Thank you, Tian, for the warm and inspiring words. Now that we've set the tone for an exciting day ahead, let's take a quick breather before diving into our keynote session.
That's absolutely right. To help us loosen up and energize the room, we have a fun little session planned for all of you. Can anyone guess what is the ice breaking game? Does anyone know? Okay. Today's fun ice breaking game is Guess the Picture. Okay, we're going to play Guess the Picture as our ice breaking game.
I'm going to tell you how to play this game. Look at the picture carefully. Second, you will have a few seconds to look at the picture. Third, when you think you know the answer, write it in the chat room. Fourth, the person with the most points wins the game. Now let's get to the first picture. Does anyone know what is this picture?
What? What?
Hmm. Oh, she. The answer is boat. Next, does anyone know what is this picture? Can anyone guess? The answer is jing, 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 jing. Tiger. Yeah.
Okay, the next picture. For the third picture, can anyone guess what is this picture? Okay, drop your answers in the comment section. Okay, I've seen a lot of comments in here. Please answer. Okay, we still got a little time for you guys to guess the answer correctly. Okay, and drum roll please. The answer is it's polar bear. Okay, we've got another picture coming up. Okay. Unfortunately, that's it for our ice-breaking session. Thanks everyone. That was a great way to get the energy flowing. Now that we're all warmed up, it's time to get inspired. With the welcoming session complete, it's time to launch into the heart of our conference. We're about to begin the keynote session, so prepare to be inspired, challenged, and informed by today's insightful presentation. Let's stay engaged and curious throughout. To our moderators, Azrael and Indra, we kindly invite you both to take the screen.
All right. Thank you, Dinda and Mita. Good day, everyone. I'm Azrael Fananlohi, and together with my co-moderator, Indra Prama Adiwinata, we are pleased to welcome all of you to today's High School Scientific Conference. We are delighted to have you with us as we explore an exciting and highly relevant topic that sits at the intersection of youth, technology, and innovation. This year's theme, Architecting Future Intelligence, the Convergence of Youth Agency, AI Infrastructure, and Scalable Venture, sets a dynamic and innovative platform for us to exchange ideas, broaden our perspectives, and deepen our understanding of how young people can actively shape the future of intelligent technology and innovation. Our first session will bring us deep into the world of machine learning and artificial intelligence, exploring the technology behind language models, computational science, and the exciting possibilities they offer for young researchers and problem solvers. But before we begin our discussion, it is our privilege and great honor to welcome Marco Cognieta, PhD, a distinguished figure whose work and expertise have contributed to the advancement of innovation and emerging technologies. To give you a glimpse into his professional journey, achievements, and contributions to this field, we'll briefly present his profile. Dr. Cognieta is currently a senior software engineer at Google in Mountain View, California, where he focuses on language modeling and the fine-tuning of large language models. His work and research span areas including LLMs, tokenization, constraint generation, and language models evaluation and personalization. He is also a co-maintainer of SentencePiece, Google's LLM tokenizer. Throughout his career, he has contributed to both research and technology industry, including his work as a machine learning consultant at chess.com and his previous roles as a researcher and software engineer at Google, where he worked on areas such as language modeling, federated analytics, and efficient on-device models. Academically, Dr. Cognieta holds a PhD in computer science from the Tokyo Institute of Technology, following his master's degree from Yonsei University in South Korea and his bachelor's degree in discrete mathematics from the Georgia Institute of Technology. His extensive research has resulted in numerous publications on tokenizations, language modeling, machine translation, and probabilistic finite state automata presented at major academic venues. Beyond his own research, he has also contributed actively as a speaker, reviewer, mentor, organizer, and advisor, supporting researchers from both high school and university levels. With his extensive experience and expertise, we look forward to gaining valuable insights into how artificial intelligence, youth agency, and scalable innovation are shaping the future and how the next generation can take an active role in architecting that future. So, without further ado, let us begin today's first session. Dr. Cognieta, the screen is yours.
Hello, can you all hear me?
Yes, we can hear you.
Great.
Your voice is clear.
Thank you all for having me. This is quite nice for me. I'd like to talk a little bit about language models at a high level, which I think is a pretty topical subject these days, and also a little bit about my specific area of research, which is tokenization. It's kind of like this niche area of language modeling and computer science that I think not very many people know about, but it's really relevant to users of language models all over the world. But the last thing I want to talk about briefly is something that's kind of dear to me, which is, sorry, I muted myself for a little while, didn't I? Should I start over? Yeah, anyway, I don't know what I wasn't muted for, so I'll begin again. Today, I'd like to talk a little bit about language modeling and language models which form the basis of, for example, tools like ChatGPT, which is something that's pretty topical these days. And then a little bit about my personal area of research, which is tokenization. It's sort of an understudied area of language modeling and computer science, but it's really relevant to people all over the world who use these tools. And then at the end, I'd like to talk a little bit about something that's kind of dear to me, which is how high school students, and those especially who are interested in science and computer science, can sort of leverage the things that they have in their advantage to do interesting projects and to get interesting opportunities and to make a name for themselves. And I really think that being a high school student is a great time to start doing these things, especially if you have, you know, if you have interests that you want to pursue, and if you're interested in computer science, especially, it's a great field to be in. So anyway, once again, thank you all for having me. This is quite nice. So next slide, please. Oh, great. Yeah, so my profile was already somewhat introduced, but I'll briefly introduce it again. So I studied discrete mathematics in Korean in undergrad, and then and the fact that I did two things I think will come into play a little bit later. And then I moved to Korea for my PhD, but I quit halfway through to join Google. And then I decided to go back to finish my PhD. So I moved to Japan and I finished my PhD there. But the whole time I was working at Google as well. So I've been at Google now for 8 years, doing language modeling the whole time, but have moved sort of all over the world. I just recently finished my PhD actually, and have moved back to America to continue at Google. And it's been overall quite nice. But my hobbies are computers and chess, and computers and chess together. And also I like coffee quite a bit. But this picture on the right seems to somehow summarize my life very well. This was at the World Championships of Chess in Singapore 2 years ago, and Google had a machine learning booth there. So there's Google AI and chess, which is a pretty good summary of my life. And I got to go visit that. So yes, next slide, please. Right, so I want to talk about language models today. And I don't really want to get too much into the details because the details change quite quickly. And there's sort of like, I could talk for 50 hours on the details, but I think that the major thing about language models that stays consistent is pretty easy to actually explain. So I assume that everybody here has at least heard of ChatGPT, but most likely uses it every day. So do I. And I think that this is going to continue for the rest of our lives. And this is an incredibly powerful technology. It does like amazing things that we could never even dream of doing before. And it does it in this seemingly magical way. But the way that it does it is actually like surprisingly simple. And so what I want to get at is, what is a language model and sort of like, how does this actually operate? And the way to kind of start this is to ask this very simple question. So I'm going to give you a sentence, and I want people to just, you don't have to type it or anything, but guess what the next word is. And also, I want you to think to yourself, how confident are you that you know what the next word is? Like if I bet you $100, would you bet on knowing the next word? And so the first one is the United States of, and no, like I think that this is quite obvious what the next word might be. And then the next one is salamat, and it could be many things following that. And the third one is, if I yawned, oh, salamat, and then I asked, what's the next word? These things all have a distribution of words that you could imagine the next word being. But frankly, any word could fit into this. Like it doesn't have to be there's no real right word. There are words that make more sense and things like that, but there's no real right word. Every word could potentially be fit into these spaces. So if you go to the next slide, we can look at some sample probabilities of what I think that the next word is. So the United States of, yeah, all right. I think a lot of people could guess that it was America. And I would say that I'm 99% sure that the answer really was America. And I'm pretty sure that the answer was not Jakarta. Although I could say that, the United States of Jakarta. For the second one, there are many different ways that I could follow up this word. There are all sorts of greetings that begin with this, and without knowing anything else in Indonesian, I would maybe assign each of these equally likely probability. So I think it's probably just as likely that each of these three words could follow the greeting, selamat. But when I yawned, and then I said, selamat, now I think I have a little bit more information. So if I'm yawning to somebody and then I say a greeting, it's either probably really, really early in the morning because I've just woken up, or it's really, really late at night because I'm about to go to bed. But it's probably not the middle of the day. So suddenly even though these phrases are almost the same, because I have slightly more context about what I'm saying, my probabilities shift a little bit. And so what I want to get at is that this is the fundamental concept of how language models work. The next slide, please. Right. So a language model is just a function that tells us, I give you a bunch of text as a context, like a whole sentence, a paragraph, books, a video, whatever. And it tells us what is the next word and how likely do I think that it is. And if we can do this well, if we can guess these probabilities well, it turns out that you can generate fluent text very accurately. You can generate text that sounds like a human. So for example, here, I have this context. After months of searching, the probe finally found ... And I come up with this list of probabilities of what I think the next word is. So maybe it's water, maybe it's evidence, maybe it's life, maybe it could be many other things. And I get this nice probability distribution of next words, and I sample from it. So I pick at random from this distribution, and I pick the word water. And I stick that to the end of my context. So now my context is, after months of searching, the probe finally found water. And then I ask again, what's the next word after this context? And now there's many different predictions. Again, beneath, on, under, trapped, above, within, all these types of things. And they all have probabilities. I sample again. I stick the word under to the end of my context. I ask again, what's the next word? I get more probabilities. And I repeat this process. So I get this context, I sample a word, I add it to the context, I sample a new word, and now I can generate text with this high probability. And this is literally exactly how ChatGPT works, just at a massive, massive scale. And so this might sound surprising that ChatGPT can do like legitimately magical things, but it's all this probabilistic process of can I predict the next word well? Next slide, please. And so this concept, we know about it really well now because of ChatGPT and things like that, but it's actually not that new. So the guy on the left, his name is Claude Shannon. And I think a lot of people don't know his name, but he is legitimately one of the most important scientists in the history of the world, solely because he came up with this idea of information theory and how probabilities can be used to compress things or to generate things or to predict things. And this was in the 50s, I think, that he came up with this. So this is almost 75 years old. And for a while, it was like this theoretical tool. We didn't really have computers, but as an example, the phone on the right is older than almost everybody in this channel, probably older than me too. And even this phone had next word prediction on it that worked in the exact same way. You got some text and you predicted the next word, and that's it. Cool. Yeah, this side is good. So these language models used to actually be really, really bad. So ChatGPT is quite good, and you expect that maybe it was always the case, but it wasn't. So let me give you an idea of what a simple language model actually does. And let's just say I look through all of the text on the internet, and I look at adjacent words, so like word A and word B, and I predict what's the third word that comes after it. So I look at all these sets of 3 words and I say, here are the first 2 words, here's the third word, and I make this giant distribution. And that becomes my distribution of text that I generate from. And so like, for example, when I'm generating text here, I would say like the boy question mark, and then I sample from the probability distribution of what follows the boy, and then ran is the word. So then I say, all right, what follows boy ran? But I've thrown away the. I generate a word fast. What follows ran fast? I've thrown away all the text previous to that. And so I generate this text, the boy ran fast. And you can imagine how you might write a program to go on the internet and scrape all these words and then figure out what's the next word, the probability of the next word. But here's a really bad case. So remember, I can only see the last 2 words. And I've written this sentence here, and I've blanked out everything but the last 2 words. So does anybody have an idea what could possibly be the next word here? It could be anything at all. It could be in the face, in the car, in the book, in the airplane, in the school, in the pocket, whatever. All these different things could be possible. But if you go to the next slide, please. If I unveil the text is, I'm a doctor, I work in the blank. And now the probability, it's very clear that it should be hospital. It's very clear it's not the face or the car or the book. And because I've only looked at the last 2 words each time, I've lost this long context. The text that came before is not included in my probability distribution. And this is how language models used to work. And so you can imagine all these situations where they can only hold a little bit of information and they lose the important information that helps you to generate good text. So next slide, please. And this is because predicting text well requires some knowledge. So just generating fluent text is not exactly the same as generating correct text. So as I said, when I said the United States of America, I could have said the United States of Jakarta. That's like a perfectly syntactically valid sentence. Nobody would say that that's grammatically incorrect, but it's wrong in some way. The United States of America is really the right way to say that. And for the next one, the capital of Indonesia is Jakarta. It's not Tokyo. And so you would have to know that it's Jakarta. But there's another aspect to this where Jakarta is the answer right now, but in a year from now, it won't be Jakarta. It'll be something else. It'll be Nusantara. And so these would have to be updated with the knowledge of modern life. And for example, the United States of America or the capital of Indonesia is Jakarta. These are things that I may have seen in, like when I've scanned the internet, I probably saw these phrases many, many times. And so I learn a really good distribution for these things. But if I gave you a totally random phrase that had never appeared in history, a human would be able to predict the next word fairly well, but a computer might not be able to. So for example, if I gave you this math problem, 425 plus 112,000, whatever, minus 7 equals what? And this probably never exists anywhere on the internet. If you search for this on Google right now, I assume you would not find this exact text. So the model you've never seen this before, and yet I should be able to answer it correctly. And that requires some knowledge, which is not just these pattern matching statistics. So in order to be able to get this right, I would have to have a knowledge of mathematics or a knowledge of geography or a knowledge of recent political events, for example, in Indonesia. Next slide, please. And so another thing is that in the past, these models used to be specialized. So like when you use ChatGPT, you can do anything you want with it. It works like amazing on every task that you ever pass to it. But this wasn't always the case. So for example, in the past, I used to have these models that were trained, for example, to translate Indonesian into English. So I made this model. I went in, I collected all of this translated Indonesian and English text, and I trained the model to have the Indonesian and the English as a context and predict the word, and I could predict a translation of the text. And so what sort of data do I need to train a model like this? I would need a bunch of Indonesian and English sentences that said the same thing that were lined up. And how many of those do you think that we have? For example, for English to German, these are 2 countries that have existed They've been allies forever. There's tons of English and German data. There's probably like, I would say, I added these books in here. Imagine there's 100 units of English to German data. But Indonesian, like there's just less English and Indonesian translated data. Just for no reason other than we exist on other sides of the world. So there's like 1/3 as much English to Indonesian data, which means that I probably can't make as good of an English to Indonesian translation model as I could from English to German or vice versa. And what about an even smaller language like Balinese? This is a language that like probably has very, very little English to Balinese direct translation. So I can't make a great translation, even worse than an English to Indonesian or Indonesian to English model. And what about a super small language like Osing? This is like essentially has no, maybe 100, maybe 1,000 sentences exist between English and Osing. So how could I possibly make a really good model that translates English and Osing text? It would be quite hard. And yet ChatGPT probably can do it. And so then my question is, I've trained this model from Indonesian to English, but you visit Europe and you want to talk to someone from Sweden and they don't speak English. Can you use your English or Indonesian to English model to talk to them? You really can't, because Indonesian to Swedish is a different problem. And how much, if we think that there's not that much Indonesian to English translated data, there's probably 100 times less Indonesian to Swedish data. So suddenly you can't do anything. So a model that works for one thing in the past doesn't work for the other things very well. And that means that these models are small and they're brittle and they don't generalize that well. So next slide, please. But what we want to do is we want to develop general skills. And so really quickly, I want to ask, which do you think is harder? As an English speaker, do you think it's harder to learn Chinese, or do you think it's harder for me to become a Chinese poet? So I'm an English speaker and I just want to read every Chinese poem in history and then become a Chinese poet. Next slide, please. To me, the answer is definitely to learn Chinese first. So if I just read every single Chinese poem ever written, I don't speak Chinese, by the way. I've read every single poem ever written. I still could not write a Chinese poem, at least a very good one. But if I instead spent a lot of time learning Chinese, and then I read just a few Chinese poems, I probably could generate a pretty good poem. It might not be that good, but it would be better than if I had just learned from reading Chinese poetry. And my point is that there's not that much Chinese poetry to read, but there's a ton of Chinese text to read. And once I know Chinese, learning from just a little bit of Chinese poetry will be much easier. And this is how ChatGPT decided to do it. Next slide, please. So the general models follow this smarter path. They learn a really generic skill that has tons and tons of data. For example, just Chinese or English or whatever language, just predicting the next word. And then they specialize on another skill that has not that much data. So once it's learned Chinese or English or Indonesian, then it can specialize on this skill like Chinese poetry or coding or Indonesian songwriting, whatever you want. And it works much better than if you had just tried to learn the specific task. And these general models can be used for other tasks as well. Next slide, please. And so these general tasks, like a general task that we could learn is literally just what's the next word. Because as I said, if you can predict the next word well, you can generate fluent text. And if you predict text well, it means that you have some sort of knowledge. And so this general task can actually work quite well for training a model to do any task. And what's really great about it is that the data we can use, instead of just using, for example, a specialized task data like Indonesian to English translation, which has not that much data, I can train on everything that has ever been written in the history of mankind. All of the internet, every book, every magazine, any language, it really doesn't matter. I can train on everything. And so suddenly I get all of this information in every language. I get tons of knowledge. I get a really great way of predicting the next word. So again, if now I say that the English to German translation data is this one unit, then English text on the internet is millions of times bigger. There's millions of times more English text than there is English to German translated text. And if you count all the text on the internet, not just English, there's 10, 50 times more of that. So there's suddenly tons and tons of data to learn from. And like back to my analogy, if I want to translate between French and English, it's much easier for me to learn French and English first and then learn how to translate between the two than just to learn how to translate directly. The next slide, please. And so what makes modern models good? It's that they don't have this finite context window. They don't get, remember I'm a doctor, I work in a hospital. They don't lose the old context. They always can see that. Then they scale. So the models get bigger in some way. It's like, it's a little bit hard to explain, but it's a little bit like if I make an engine in a car bigger, typically the car can go faster. Or if I make an airplane engine bigger, the airplane can carry more people. And I have more and more and more and more and more and more data. They use all of the data available to it. And then they also have things like tools, which are, for example, they have internet access, which like an old language model might not. And they can write code, or they can access knowledge banks. They don't have to memorize everything. They can, if they don't know the answer to a question, they can go look it up somewhere. And these are really powerful things that make models quite good. And one of the people that has, you may have heard a lot about GPUs these days. That is the scale, and the why these models are able to scale is this hardware that people make. And this actually, the idea behind ChatGPT has existed for 20 or 30 years, but until about 2018, the hardware required to do things like this it didn't exist. And NVIDIA, and the guy in this picture is Jensen Huang, the CEO of NVIDIA. By the way, NVIDIA is right across the street from me. It's quite nice. Became essentially the richest person in the world because he made the hardware that was good enough to train these models, and everything runs on these models. So quite a nice bet by that guy. The next slide, please. And so, yeah, as I said, one model can do many things. And the reason is because text is sort of a universal interface. So you think of just generating text like word by word, but text can actually describe many, many things. So for example, it can describe mathematics or how to use a computer. And so ChatGPT might have something in it called a tool call, which is it can describe by text a tool that it wants to use to get an exact result. So it doesn't have to do things itself. It can offload tasks to other things. And as an example, if the user asked about, hey, solve this integral for me, ChatGPT might generate this text that says, the user asked me about this integral. I'm not going to say the integral, whatever, yeah. I need to solve it, but I don't really know how to solve it. I'm going to call a tool. And so it says tool call. And now the prediction is, which tool should I use to solve this integral? And it has a distribution over, should I use an integral solver? Should I use a calculator? Should I look up the weather? These are all different tools that I could use, but an integral solver seems like the right one to do. It calls the integral solver and passes in this context. And the integral solver, which is like a program somewhere that somebody has written, returns the answer to it. And the answer comes back as text. So all of this process was done by text, but it uses external tools and it gets answers back and it converts mathematics to text and answers back to text. And these are all really powerful things that a language model can take advantage of because it can do many things and because there are lots of things that you can describe by text. Next slide, please. And many other things are like predicting the next word. So these are GIFs. These were supposed to play video. Sorry, this is my bad. But the one on the left is Tesla self-driving cars. And these are amazing. You can get in a car, doesn't have a driver, it drives by itself. And this is sort of like predicting the next word, where instead of predicting the next word, what I'm predicting is what's the next action that I should take in order to safely get the passenger to the location. And that balances things like which direction should I take? Should I avoid hitting a car? Yes. Should I speed up or slow down? Is there a stoplight? Things like that. And on the right is Lee Sedol, who is one of the best Go players in the world when he played AlphaGo, a program that was designed to play Go. And this is similar to predicting the next word, but instead AlphaGo is predicting what's the next move that I should make in order to maximize my chances of winning. So whereas ChatGPT is predicting something like what's the next word I should take to maximize the correctness and fluency and helpfulness of the answer that I provide to a user, these two systems are predicting the next action or the next move that does something similar. What's the best way to reach my goal? So this is a really general phenomenon. The next slide, please. And so now I want to link this back very quickly. This was also supposed to be a video. I realized that this would happen as soon as I saw the last slide. I want to link it back very quickly to what I actually work on at Google. And I work on what's called keyboard language models. So when you're on your phone, if you have a Samsung or an iPhone or a Pixel, hopefully, and you type, sometimes the next word comes up, or it autocorrects your text. And these are actually the exact same thing. So we've trained all these models that say, here's what users typically type, and here's how we can help them to correct their text. So when people type a word that is very surprising to the model, like for example, if the model has a context and it says, I think that the next word is cat, but a user actually types the word VAT, V-A-T, so it's right next to it on the keyboard. That's a very surprising thing because the probability of cat is quite high and the probability of VAT is quite low. And so the model might think that the user made a mistake and will correct it. And so by having a good idea of what the probability of the next word is, we can make these models that help you type faster or more accurately. Or in the examples that I was supposed to show here, we can actually type in multiple languages at once. So in the one on the left, as you start typing in English, it predicts English text. Or if you type in German, it predicts German text. And on the right, if you type in the Latin script, it will predict Indic script. It will predict a different language, like a transliteration language. And all these things rely on the exact same idea of predicting the next word. So the next slide, please. And I'm running a little bit low on time, so I will speed up. And so the other thing that I work on, which is what my PhD was in, is this idea of tokenization. And so the question is, what does a model actually see? So we were passing it this sentence, like, for example, after months of searching, the probe finally found water. But what does the model actually see? Does it see words, or does it see the sentence altogether? Or maybe it sees letters by letter. What about numbers? What about punctuation, spaces, things like that? And what it actually sees in real life, like when we actually implement these models, is something in between words and letters. Next slide, please. And these are called subword tokens, which is why we call it tokenization. And they have this idea of a model has to have this fixed vocabulary of possible chunks that it can actually read. It can't, like for computational reasons, it has to be this finite vocabulary. But what actually counts as like a word that a model might want to see? So for example, for this word run, how many different forms of run are there? There's run, running, runs, ran, runner, runners, runnable, rerun, reruns, rerunning, reran. There's almost an infinite number of words like this. So we can't possibly encode all of these. And for example, for numbers, there are an infinite number of numbers that could possibly exist. I can't encode them all. And what about this third one here, which is a made-up string of letters? That's not a word, but somehow I want the model to be able to read it somehow. And there's just too many to list. So we use this thing called subwords, which are like common pieces that appear in many words. So instead of reading word by word after months of searching, the probe finally found water, we break it up into pieces. So for example, after month and S, and now this month plus S combines together to make months. But I only need month, I don't need months, I don't need monthly, I just need month and S. And of searching, so again, I've split up this word into common pieces. The probe finally split up again, found water. And so I can make this finite list of chunks that appear very often, and that's what I feed the model. The next slide, please. But what I work on is that these tokenizers, the things that chunks the text, they work differently for different languages. So for example, for English has really great tokenizers because there's a lot of data. And so, for example, this is a talk about language models. It chunks every single word into just one token. So like talk isn't broken into two pieces, for example. But for other languages, like for Indonesian or for Balinese, because these don't have as much data, the tokenizers are a little bit worse, and they chunk text into like smaller pieces that aren't as meaningful. And so these colored chunks are like how the model actually sees the text. And sort of the more chunks that there are, it means that the model has a harder time processing it. But that's not fair. Why would English be good, but Indonesian shouldn't be good? That's sort of like unfortunate. And it actually comes back to bite users in a different way, where we charge users by the token. So however many tokens you input or generate, that's how much you get charged to use the models if you are using like a paid plan. And so it's unfair to non-English speakers to have to pay more in order to use the same tool. But it's solely because of this problem of tokenization. So my work was on making tokenizers more equitable across different languages. So like I should pay the same amount if I expressed something in English as I should if I expressed it in another language. And the next slide, please. And it gets quite bad for other languages. Like, for example, this is a Korean one, and it says in Korean, this presentation is about language modeling, but you see the question marks down here? This means that the model can't even read this text at all. It just doesn't know what it says. It just throws it away. And so suddenly this model can't even process this text in any way. And that's definitely not fair to, for example, Korean speakers. And so this is what I work on about how to more equitably process text in different languages. So the next slide, please. I see I have 10 minutes left. Okay. I want to switch gears now. Just very quickly about what I think it means to be a good scientist and what I think that it means to be a good scientist when you're in high school. And this is very important to me because actually my career goal is to become a high school science teacher. And when I was in high school, I had really helpful and really supportive teachers that gave me really great opportunities. And it set my life on a different trajectory that I would not have been able to do otherwise. And I think that it's not actually that hard to do if you do it right. So I have a couple of things that I think make people a good scientist. And that's to do more than one hard thing at once. So a lot of people will try and do sort of, I want to learn how to be a chemist or something. And I think that it's good to be like, I want to learn how to do chemistry plus computation. So computational chemistry or chemistry plus botany. I want to do something interesting with plants and chemistry. And in my case, it was I want to do something interesting with mathematics and computing and Korean. So for example, when I studied computer science in college, I also studied Korean. All of my work is on Korean language modeling. When I did grad school, I moved to Korea. And then I moved to Japan, I guess, which was kind of a curveball. But it's sort of you do two hard things at once. And the second thing is that you should always try and break everything you play with. So like you should, this is especially true for computer science, but like when I use something, a program, I always try and think, what's the worst case? What's the worst thing that could happen if I messed with this? How can I break the assumptions that the creator made, the programmer made, as much as possible? And this is a really powerful skill across all of science and all of academia, and actually outside of that as well. And the other thing is that, oh, sorry, could you go back one slide very quickly? The other thing is to read a ton. You should just read so much. It doesn't matter how much you remember deeply, but if you find something that feels right, and like you should feel it kind of in your chest and in your head, you should deep dive on that. And the reason is because knowing what I don't know, so knowing the name of something, even if I don't know that much about it, is much easier for me to find out the rest about it than if I don't know what I know. So it's called a known unknown versus an unknown unknown. So if I've read a bunch and I come across a problem that I've seen before, I can do much more about it than if I come across a problem that I've never seen at all. So read as much as you can. The next slide, please. And then I want to talk really quickly about something called your luck surface area. And this is where I think once you're in high school, this concept starts. And about when you finish college or when you finish, if you do graduate school, this concept starts to slow down. So you're just at the beginning of when you can start increasing your luck surface area. And your luck surface area is something that is like increasing the chance that you get opportunities to do cool things that are interesting to you. And you can increase this by doing interesting things and talking about it to all the people that you know. So the more people you know, the more you talk about it and the more interesting things you do, these things get sort of propagated and they sort of start to spawn new opportunities. And you have to be really high agency. And by that, I mean, you should just do the things that you want to do. So don't ask to do something, just do it. You should just email people if you're interested. You should just start a blog. You should just do the thing that you want to do. And on the right here, I have this Steve Jobs. You can just do things. This is like the most powerful mantra. You can just do it if you want to. And to be really generous with your time. So say yes to things, meet people, help people with things. These all help you increase your luck surface area. And I'll give you an example on the next slide, and that'll be the end of my talk. So I'll give you an example of how myself and a student of mine increased our luck surface area and how it helped us in the end. So on this slide, the blue ones are things that were designed to increase your luck surface area. The red ones are really positive outcomes of it, and the black ones are just things that happened to fill in the story. So many years ago, I became very close with one of my high school teachers. So I was increasing the number of people that I know. After that, I asked to teach a class at my high school after I finished college. So this was doing something. And I taught this student. That's what happened. And then 8 years later, the student emailed me out of the blue. And this is him increasing his luck surface area. And so we got together and we worked on a project together. And as an outcome of that, we won an international chess machine learning competition. And as an outcome of that, we wrote a paper which increased our visibility. And an outcome of that is that he got a job offer from Amazon. And then later, we won a second competition. We wrote another paper. We met more people. I got a job offer. He got a job offer. All these wonderful things happened just because we both sort of started to decide to increase our luck surface area by reaching out to people and doing interesting things and talking about it. And he was a high school student. You can do all of these things as a high school student if you're deliberate and high agency and you feel like you have something interesting you want to work on. So, yep, thank you.
All right, thank you. Wow, I mean, that was a very powerful message, and overall, that was a very powerful material too. So, yeah, once again, thank you very much, Dr. Koknyada, for giving that presentation, that wonderful presentation. I mean, I think we all learned very much from it, from this session. And I think our audiences are eager to ask questions right now. So I would like to invite everyone, to kind of just raise your hands or chat your questions in the chat box in this Zoom webinar. If you have any questions regarding Dr. Koknyada's presentation, I will pick you out and then you can talk to him personally.
Right.
So anybody, just give your questions in the chat box. Any questions? Or raise your hands. That's okay too.
Can you, yeah.
There's a question. Do you want to answer it straight away, or you want me to read it?
I can read it out if you would like.
All right.
And then answer.
Sure.
Yeah, can you explain large language model hallucinations, like what's actually happening? And it doesn't happen that often, but even every language model, ChatGPT, Gemini, Grok, all of these do it. Yeah, this is a really good question. And it's because, as I said, we're predicting text probabilistically. So when I said the United States of, and the next word is America, but I wanted to add in all of these other options that are very low probability, like Jakarta or the United States of the sun. These are nonsense words, but they all have not zero probability. And the reason is because we want to make sure that models can generate anything. There's not text that it like can't possibly generate, because there's nothing to say that there's not a context in which the answer, the United States of Jakarta, isn't the right answer. So like we always want to have a little bit of probability available to any possible next word, and we sample from it. So we roll a dice. And even though it's 99.9% the United States of America, there's a 0.1% chance that it generates Indonesia or whatever. And if you do this billions and billions of times, you're guaranteed to see these other random words. And that's just for a case where the next word is like something really likely to be America. But if it's some more vague concept, you can get into these areas very quickly where if I sample one word wrong, all the subsequent words are like based on this previous word, and I start probabilistically generating text that sounds plausible based on what I've generated before, but what I generated before was wrong because I sampled something weird, and then you get hallucinations. And these are fixed by a few, they're not fixed totally, don't get me wrong. This is a really big problem. It's a fundamental problem of language models, but they're fixed by making it so that language models rely more on looking things up. So like, as I said, they have a tool call that can look up the weather. Why would I ask the language model, what's the weather today? It can't probabilistically generate the answer to that. It doesn't know what the weather is, but it knows it has a tool to look up the weather, or looking up knowledge bases, or just having better models to begin with. So like in the past, language models used to hallucinate a ton. And as models have gotten better, they just don't do it as much because their probability distributions are better. But the main thing is that they now are learning the cases where it's better to look the answer up than it is to just make something plausible up. But this is a real problem. It will persist forever. And if I had to make a bet, it would persist. It will always be a little bit of a problem. So like, you should take these things with a grain of salt and not rely so much on the outputs of them that you don't think for yourself, things like that. That's a great question. Hallucinations are a real big problem. The next one is, as you said, since models pick the next word using recent patterns, what happens when two totally different meanings fit the context equally well? How does the prediction engine break that tie without losing the user's intent? It's really tough. This is another problem. The less context I have, like if I just said like, ChatGPT, finish this sentence, what could it be? It could be any word is the next word after the. It's impossible to break the tie. It will just generate something. And so what makes these models really powerful is that you can feed in tons and tons and tons of data. So like if I was like, write me a story, it could start generating stuff, but it's probably not anywhere close to what I want. But if I dump in 10 paragraphs of context about what I want the story to be like, it'll generate something that's pretty close to my intent. And it just depends on, actually, here's another example. Remember my very first example of Salamat, where there's many different possible equally likely continuations. But if I give you the context that I'm tired, the answer becomes much more likely to be something about it being very early in the morning or very, very late at night. And so the more context you give the model, the better the predictions can be. Let's see. I wonder, does a language model actually understand? Yeah. Oh, these are hard questions. Does a language model actually understand what our words mean, or just predict the next word because it was the most likely based on the pattern it learned? This is a great question, and I do not have an answer to it because this is not a computer science question. This is a philosophy question. What about me? If you asked me to predict the next word, I understand what you said. I understand, what you meant for me to do, but what does that mean? I've seen this question. People have asked me to predict the next word before. So I've seen that pattern before. Is it just because I've seen this question before, or is it because I understand what you're saying? I guess really it's that there's a philosophical question of what's the difference between being really, really good at predicting text because I've pattern matched it and being really, really good at predicting text because I understand it. Like, understand, I think that the problem is that the word understand is not descriptive enough. What does it mean to understand text? That I've seen it before, even if the model hasn't seen it before, sometimes it gets the answer right. So it's not that I've seen it before. It's not pattern matching. It's something else entirely. And I am not the person to answer that question. This is a really, really hard philosophical question about like what does it mean to be conscious? What does it mean to be sentient? What does it mean to be intelligent? All these things are problems that are like in the purview of spirituality and philosophy more than mathematics. Thanks, though. This is a great question. How can LLMs achieve reliable reasoning and factual accuracy while minimizing hallucinations, bias, computational costs, and catastrophic? All right, maybe I should have done a more advanced talk if we're talking about continual learning and catastrophic forgetting. This is a great question too. So I don't know how much everybody knows about this, so I'll give the example again about the capital of Indonesia is Jakarta. But in 1 year from now, I don't want the models to say Jakarta. I want the models to say Nusantara. If I'm pronouncing that wrong, please forgive me. I've never been there. But the answer will change because Jakarta will no longer, actually, we'll see if Jakarta is no longer the capital, but potentially Jakarta will no longer be the capital. And so the answer will change. And so the model has to update what it knows. But will it now forget all of the things that it knew about Jakarta? If I ask about the capital, will it, and I mean the new capital, will it answer as if I meant the old capital? Or will it answer as if I meant the new capital? There are different answers that might come up. Like what's the best restaurant in the capital? Will it answer about Jakarta or the new capital? Who knows? And so continual learning is to enable models to update their weights, update their knowledge without recreating them from scratch. Recreating them from scratch is very expensive. Like it costs hundreds of millions of dollars. It's energy expensive and things like that. It takes a long time. So you don't really want to be doing this every time a new thing comes out. And I really think, again, the answer is that we're getting quite good at augmenting language models with the ability to look things up. So like, I don't have to go back and learn everything I've ever learned every time I learn a new fact. I can just reference it in some way. Or like if I make a new friend and I get their email address, I don't have to update everything I've ever learned about email addresses before. I just go look up what their email address is. And analogously, by enabling language models to have these knowledge bases that are able to be updated easily, or these tools that they can search things or look things up or query an answer from somewhere, this almost enables continual learning in a way that like sidesteps the computational costs of doing it. But this is continual learning to me is the like next big problem in language models. Like the team who, there's two big problems I think that come up in language modeling, and the first one is called RSI. It's recursive self-improvement. So it's creating a language model that is able to design a plan to train a language model that's better than itself. And once you can do that, you can do it again, you can do it again, and whoop, 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 and now you've suddenly got an infinite loop of better and better models. And the other one is continual learning, where it costs so much to update language models, and it's so resource intensive that I don't want to do it. So I need a way to continuously update the knowledge of a model without destroying what it did. And the people that solve RSI, they are going to be the most famous scientists in history. They'll be the richest people of all time because it ends the problem altogether. But the people that solve continual learning, if they solve it before RSI, that will be the next huge, huge breakthrough. Sorry, I want to move on so that I can get to everything. So I have a question. Are large language models better used as tools to assist humans, or could they eventually replace humans in processing information? It's true, they could. Right now, it's better to assist, or even not to be used at all. There are areas that it can be better to just let a language model do it. And more things are becoming that way. But I think even if language models are better than humans at many, many things, there's like a a fundamental reason that we shouldn't just let language models do everything. And it's because like we should allow humans to have some purpose. And like I don't mean calculating my taxes. I mean creating art and literature and telling stories and the things that make us human are things that we shouldn't be offloading to computers. And I also think that even if computers get better than people at lots of things, there are reasons to want humans to still do those things. Like this is the analogy that a lot of people use. Like for example, I gave the one of Lee Sedol playing Go against AlphaGo. AlphaGo beat him. AlphaGo is better than any human ever at Go. But people still play Go, and people still watch human Go, and nobody watches computer Go. It's because it's interesting and it's human, and it grounds us in a way that computers can't. And so these are like I honestly feel bad for like our generation and the next generations because we're having to grapple with this problem of like suddenly there are these things that can replace us in almost every aspect of our lives. And what should we do about that? And the answer is to, I mean, I don't know what the answer is, but my answer is, to remember that humans possess interesting qualities that aren't just supposed to be maximized by a computer. Like there are things that I value about work created by humans that are inherently because a human created it and not because it was created at all. So yeah, thank you. I think that I went a little bit over time, so I'm sorry if I didn't get to everybody's questions.
All right, thank you very much, Dr. Cogneta, for answering uh, those wonderful questions. And thank you to everyone for the thoughtful questions and active participation throughout our Q&A session. I hope this discussion has helped you gain a deeper understanding of the materials presented before. Before we move on to our next session, let's take a quick moment to put your knowledge to the test with a short quiz. And here's something to make it even more exciting. There will be rewards for our quiz winners. All of the questions are based on the materials and insights shared by Dr. Cogneta, so I hope you're paying close attention. So without further ado, I invite everyone to scan the barcode displayed on your screen and join the quiz. You can then enter your full name and click start. If you have any questions, you may ask in the chat box. The questions will be in multiple choice formats, so just do your best and have fun. Good luck, everyone. All right, so the first question, what is the main purpose of machine learning? This is fairly basic, so everyone just pick the correct answer from your devices and we will move on to the next question. There are four choices to improve how computers manage system resources. All right, move on to the next question. In supervised learning, a model is trained using, is it data mainly containing images and videos, labels or expected outputs, data generated with prior categorization, or collected with predefined information? You may put it in your answers. If you're paying attention, I'm sure you can do the questions just well. All right. Next, we're moving on to the third question, which is an example of machine learning. Is it adjusting settings using fixed instructions, recommending videos based on viewing behavior, organizing files according to their types, or moving files between different storage devices? Put in your answers. All right. Now the fourth question, what happens when a model overfits its training data? Is it Will it perform well on training but poorly on new data? Will it perform poorly on the training data? Does it need more data to improve its training, or does it become too simple to detect patterns? You may put in your answers now. All right, moving on. What is meant by youth agency? Ooh, is it a group focused on youth employment programs? The ability of young people to make choices and create changes, a stage when teenagers develop into adults, or a legal right for minors to manage businesses. Focus on the word youth agency. It is basic. I'm sure you can do well. Right? Next question. Why is youth agency important in AI development? Does it allow young people to replace older developers? Does it help companies delegate programming to youth? Does it reduce the need for technology regulations? Or does it bring diverse views and helps reduce algorithmic bias? All right. Next, which is an example of youth agency in AI? May see the choices below. There is avoiding digital platforms due to privacy concerns, following technology news from online influencers, using social media recommendations without checking them, or building an AI tool to analyze local climate data. Example of youth agency in AI. Right. Next question. Moving on. What is a major challenge to increasing youth agency? So how do you, what is fairly the major challenge in increasing youth agency? Is it the increasing access to online educational platforms, excessive funding, or limited youth access, or even growing interest in technology among young people? I think this is logical, so the answer is fairly easy, right? Now you may continue to do the game on your own, and remember that there is a prize for the quiz winner. So stay excited, everyone. We have 1 minute left for the quiz session before we begin to the next material session. Oh, all right. So I think the time's up for the game session, and for the last words, I would like to conclude this presentation. So we have officially reached the end of our quiz. I hope you all had fun and enjoyed putting your knowledge to the test. To conclude, we have seen how language models have evolved from relatively simple systems with limited context into powerful technologies, capable of processing vast amounts of information, maintaining context, and even working with external tools. At the heart of this development is a simple yet remarkable principle, which is predicting what comes next based on the context available. Through processes such as tokenization, language models can break down and understand different forms of language, while their effectiveness depends not only on producing fluent responses but also on knowledge and accuracy. Ultimately, today's session reminds us that the power of modern AI comes from its ability to learn general patterns from enormous amounts of data and apply them to countless tasks. Beyond the technology itself, however, there is an equally important message for us as high school learners. Stay curious, keep experimenting, take initiative, and actively create opportunities through continuous learning and meaningful connections. Now, to continue guiding us through the next session, I would like to welcome my fellow moderator, Indra Prama Adiwinata.
Thank you, Dr. Koknyeda, for sharing your valuable insights, and thank you to my partner Azrael for guiding us through that stellar first session. Hello, everyone. I hope you're all still energized. My name is Indra Prama Adiwinata, and I'll be moderating our second key session for today. The discussions we've unlocked so far have been nothing short of inspiring, and the energy in this virtual room proves just how eager we are to shape tomorrow's innovations. Let's keep that intellectual curiosity burning bright as we open the door to our next major session. Our next session takes on an extraordinary edge as we welcome Nathanai Praninatawi, Master of Science, the esteemed CEO of AGI Cafe Company Limited, whose groundbreaking contributions have consistently set a benchmark for excellence in this domain. To better understand the profound perspectives he brings to the table today, allow me to share a glimpse of his background and academic profile. To give you an idea of who we are learning from today, Mr. Nathanai Praninatawi serves as the Chief Executive Officer and Chief AI Officer at AGI Cafe Company Limited. Way back when he started, he brought a massive amount of technical leadership, leading executive energy and core AI architecture for over 7 years. Beyond leading his own company, he acts as an AI technology advisor for enterprise clients and deep learning.ai ambassador, and even founded a massive Python programming community, reaching over 17,000 active followers. He has also delivered technical keynotes for global giants like Google, AWS, TensorFlow, universities. Holding official NVIDIA certifications in generative AI and agentic AI, he brings incredible industry expertise straight to our virtual stage. Looking at such an impressive track record and visionary leadership at the helm of AGI Cafe, we truly look forward for an eye-opening exploration and gaining fresh perspectives from your insights today. Without further delay, it is an absolute honor to hand the virtual floor to Mr. Nathanai. The screen and time are yours.
Okay, I will share my slide. Can share my presentation. I just send a request for sharing the slide. Okay. Okay. Good morning, everyone. Thank you, my friend Octa, for inviting me to speaking today, and it's great honor to share my experience here. Today, I will sharing my experience and knowledge and inspiration talk about my startup, AGI Cafe, the journey of AI global startup, and let me introduce myself. My name is Job. You can call me Job. I'm CEO and Chief AI in my startup, and yeah, I have a lot of many experience of more than 7 years. Yeah, but about me, I just a regular person, same as you are, and yeah, but I have a big goal for make the AI and make the technology better for my country and many countries. It's my startup. Okay, it's my startup. You can search the link and search name of my startup. You can show many of my project, show many of my experience, and also a collaboration and partnership with the NVIDIA official for the Inception program for startup. And I host many events collaboration with Aribaka also, and I host the hackathon for students and for many Thai people showcase about how can use the AI for make the use case. For example, the education use case or the agriculture use case or many use case that students want to develop using the AI. And yes, I host many events also, and in this year I think more than 5 events, and I invite the guest speaker from the international, like the IBM, like the Hugging Face, like the many kind of the speaker come to Thailand to talk about and speaking about the AI. Yeah, many event I invite the VLM, invite the embedded OEM, IBM, and AI engineer from Switzerland, and Agoda, and AI engineer from UK. Yeah, to Thailand to sharing their experience to students and Thai people. I think it's good for for sharing the experience, not just the technical session, but sharing the real experience for their job, like the data engineering, from inspiration the student for and Thai people for actually understanding daily life of their job. That's why. Okay, let me introduce my journey also. Firstly, I found it's my third startup. I failed twice for my first and my second startup. Yeah, not survive twice. Fail. And I'm still standing here because failure was never the opposite of success. It was the tuition. That's why. And I also researcher also. I graduated the master degree and I published the paper to South Korea and yes, and to the South Korea. It's about the agriculture, the agriculture product for use the supervised learning for anomaly detection, for the quality inspection of product in conveyor belt system, like eggs, like the canned food, like many kind of product. And also this is my second startup that failed, that I failed previously, but it's good. I think it's called the Push Noise, the Thai agriculture platform for the smart Thai agriculture platform, focused on the three main principles. Simple, easy to use, cheap, affordable, efficient, high efficiency. Yeah, and I not just build the software, but I develop the hardware also. It's called the Vision AI Box. It is integrated with the drone for flying to inspection to the Thai local farmer, like the longkong, like the mangosteen, like the mango, something like that. Yeah, but for students who want to build startup, I recommend you need three kinds of this. The first one, you need to attend to the builder project and attend to the hackathon. The second one, you need the real world experience. You can contact with your teacher, contact with your senior for get to know more the experience. And the third one is about the growth mindset and soft skill. You need to communication closely with your friend, doing more the group project for better communication as well. Okay, is my research. That's why it's quite important because if you bring the research to the product, it is good for you because it's hard to develop this one, right? Yeah, it it's make 1 year or 2 years for develop the papers, and if you can make the paper to transform to the product, it's good for you. Yes. The first one is the Thai agriculture product I published to the South Korea, and the second one I use the zero and fusion anomaly classification for the Thai system and electronic device as well, using the skip retrieval augmented multimodal. Yeah, it for simple for simple things, it is about you can using the AI for detect the anomaly without the training data, without the labeling data set. If it's the self-supervised learning, the AI can self-adaptive learning for themselves, for itself, right? It's good. You don't need to prepare the many kind of labeling the data. Don't need to take a time for training, but only thing you need to the calibration the model, and using the prompt, using the image, and use the zero and fusion model to supporting set for make the AI can accept the feature and understanding the the goal, and and the AI can predict the anomaly area and classify the anomaly as well. Okay, next step. Next step, I think it's 2026. You need to understand the AI era. I recommend you the three things that you need to understand. The first one, space is the only mode left for the historic pace. And the second one is about a systematic shift. AI is not a feature, it's the foundation. And the final one is about the bottleneck. It isn't the technology, it is us. Readiness is the constant. Yes. Okay, and the first one is called speed. Is the only mode left. The historic pace. When AI accelerate everything to historic pace. Ideas alone are worthless. Execution speed is what win. I recommended you for if you have the idea, try to execute your idea to the real project, not just the thinking. If you thinking, it's not proof anything. That's why I recommend you if you have the idea, the crazy idea as well, any idea, you need to execute that to the real project, transform that to the real project, the real world project. Okay. And the second one is the AI is not the feature, is the foundation. It is the keynote from the Jensen Huang, the CEO of NVIDIA. I attend, I think the last 2 months to the Taipei. Sit sit down and listening the Jensen Huang talk about the compute is revenue. I think it's good for this year. That's why, because AI can't just be a both on feature. It has to be embedded in the business model from day one, or you will be replaced by someone who does. That's why I think it's good. If you have think about your project, you need to think about your business model also. That's why if you build the project or AI software or AI application, but you don't know your target customer, you don't know who can use your product. It's not good. That's why. I think the third one is the bottleneck is not the technology, is us. Readiness is the constant. The technology is available. Is people and organization that left behind. That is the real concern for startup today, because I founded two startup before, and I also employee of the big tech company in Thailand and international. I found the people organization develop the solution too slow, because it have many constraints. If you attend to the big tech, it have many constraints to use the new technology, to use the modern technology. That's why. But for startup, I think it's good if you have the good CEO and the good mindset CEO. You can use the many technology and modern technology for build many things better. That's why. I think for last year I become to the speaker with the Google Cloud event. I talk about the Google ADK is called the Agent Development Kit and A2A agent to agent protocol for the computer vision application as well. I think it's good for you for student, because this year it's the agentic AI era. If you uh, know about the agentic AI, how develop them, how to evaluation them, and how to deployment the agentic AI, I think it's good for you for student as well, because today is the agentic AI era, and it's not hard, it's easy. If you take a look and search something about the agentic AI, you can use the agentic development kit from the Google, and use the A2A protocol to connect the sub agent, multiple agent, to build the simple project or simple product. I think it's better. I think I attend the NVIDIA GTC Taiwan, and in this year I saw a lot of things is the quite amazing. I think it's about the robotics AI and the agentic AI, many robotics and many agentic AI that automation everything. I think the technology shifts so fast. Okay. In this year, I think AI agent change future forever if you have the idea and you can spawn the version of you, but many experience, right? Because if in the past, if you need to build something, you need to hire some people. You need to hire the AI research. You need to hire software security because you don't have the experience. But nowadays, you can spawn many sub agents, many the software security, many financial analysts, many operation support for building your product, for building your own application. I think it easier and it's easier to before. I think it's better for this year. Yeah. Okay. Yeah, and I think I have a many Singapore collaboration with my friend and with the Tencent and many kind of Thai of university. I the MOU many Thai of university as well for sharing the experience, the global experience and many project to the student for student internship as well. Okay, many kind of. And I also September 6th, I also hold the VM Bangkok Day. It's collaboration with the international. My company and many kind of partner come to Thailand for sharing to the students, sharing to Thai people as well for the deep AI infrastructure. I think it's quite good because nowadays it's have many AI application layer. Everyone can build the AI application layer, but for the hardest part, it is the AI infrastructure and AI optimization. And many people doesn't know how can optimize and how can build a good infra. That's why I host the event. I think it's good for the student. It's good for the many people. Yeah. Okay. I think that why I told you is important because if you go to the YouTube and search the NVIDIA GTC keynote 2026 from the keynote speaker from the NVIDIA for the Jensen Huang CEO is more than 35 million. It's not a concert, it's not the lyric, it's not a music video, but it's the technical session, something like that. It you see the number, right? It's quite important that you need to you to search and follow after this. Yes. It's me. After me is the NVIDIA Vera Rubin. It is the data center from the Frontier AI. Now the model that you use, like the ChatGPT or Gemini or many AI models deploy on this hardware on the data center. And then the live one is the robotic AI. I think it's from Intel and it's one-to-one sizing. And NVIDIA it have the many kind of layer, application layer, models layer, platform layer, chip layer, energy layer, because for the building the AI model you need to concern not just the application layer, it's model and platform and chip and energy layer. That is important things. It also if you need to build the effortlessly or something you need, it's the big picture. Okay, I think I go to the okay to the historical AI transformation. I think 2022. The ChatGPT release the foundation model called the GPT model is from the generative pre-trained transformer. It's a multi-turn prompt and it's intelligent model for can answer your question, the generative AI, right? And 2025 we have the DeepSeek. It's listening enable reflection for better outcome. And in this year we have the open call. I think everyone know about the open call. I think it's good. It's for the self-evolving agent working on your behalf. Okay. Okay. I think it's for the agent, it's combined between the model and harness. Model is like the ChatGPT 5.6, Gemini, something like that, and harness is the how make the model can execute the tool. If you use the code or codec or anti-gravity, I think it is different harness for you need to explore and try by yourself which one is suitable most for you. It's combined about the context, observe, listening, and acting, and the memory also. You need to input the prompt, input the orchestration, and it's the process for looping the context, looping the observe, looping the listening, and after that we have the output for that. Yes. Okay. 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 I think it's deep. Okay. Okay, I think I think I will show you about the robotic AI. I think it's good for you if you want to build the hardware, also not just the software. Because I think in this year the robotic AI developing better for the past in the past, right? It is the Unity H2. We have the Jetson Tor onboard compute, and have the Unity and Finger and software is called the NVIDIA Good for data generation and policy validation. Yeah, you need in this year, we have the specialist robot, we have the generalist robots, and the new one is called the generalist plus specialist for the deep proficiency. And for the anatomy of autonomy of the robotics, you need to have the memory, cognition, perception, dexterity, role model control, and navigation, and functional safety. I think it's good for you if you interest about the robotic AI. It's not just the software, it's the hardware, it's the real thing. It's real thing. Okay. I think it's I think the last one, for the end-to-end robotic development workflow, you need to collect the data for the data streaming, collect the data, use the for the AI and generate the data, use the digital twin for the real to simulation, and you need to simulate the high fidelity rollout, and you need to training and evaluation for scaling, and the final one you need to deploy to the hardware. Okay. I think that's all from me. Thank you, and you can follow me to the LinkedIn or the Instagram, my company Instagram. Thank you very much.
That was an exceptionally insightful presentation. Thank you so much to Mr. Nathanai Pranina Thewi for walking us through AJ Cafe's incredible work in bridging digital intelligence with physical systems and local infrastructure. And as well, thank you for sharing your experience and everything. Personally, I believe how this approach isn't just a distant theory, but something tangible we can deploy right where it is needed the most. Thank you for your insights. Now we would love to open up the floor for our Q&A session. Whether you want to drop your questions directly into the Zoom/YouTube livestream chat box or raise your virtual hand to speak up and ask your question when I call your name. Feel free to share your thoughts, reflections, or real-world scenarios you'd like Mr. Nathanai to expand on. Okay, for participant Ahmad by Haki, you may ask your question right now, and you may turn on your mic.
Okay, thank you for your opportunities. Good morning. Let me introduce myself. My name is Ahmad Bayaki. I would like to question first itu will the emergence of custom chips from startup or major cloud providers truly democratize access to AI infrastructure, or will it simply shift the monopoly to a different ecosystem? Next, in the context of data sovereignty and national AI, as regulations such as the AI Act in Europa and data sovereignty issues become increasingly stringent, how can AI infrastructure startup navigate the complexities of cross-border legislation without compromising the pace of their innovation? Next, as public data on the internet begins to run out for training AI, how crucial will the role of startup focus on synthetic data, infrastructure, and the curation of high-quality data before the future development of AI? Next,
Okay.
regarding the AI energy crisis, where AI training and inference require massive amount of electricity, how can AI infrastructure startup effectively balance the pursuit of greater computing capacity with the demand of energy sustainability? Thank you.
Okay, I think it's good question. Yeah, many details. Okay, the first one I think it is the for the sovereignty AI and national AI. I think it have a regulator. Yeah, for the example the EU AI Act, and in Thailand it also have the EDA the legal from the government, the AI legal from the government as well. Yeah, I think. Yeah, but for startup, you need to for the AI startup, you need to follow the government from your country first. Yeah, from your country first for make your can development and scaling your product first. But if you need to extend it to many countries like the EU, like the USA, you need to follow the UAI Act and in their country also. But first thing you need to follow from your country first. Yeah. Okay. Yeah, I think it's not hard for follow the regulate for the follow the regulation. I think in this year it's quite flexibility quite flexible. It's quite flexible if you build a quality product. I think it's not have any problem. Okay, I think the second one is about the energy crisis, right? The energy crisis and the training and inference require the massive amount of the electricity. Yeah, I agree with that. But for my startup part, I developed the AI infrastructure for the SME and enterprise as well. Yeah, and Thai government as well. I think you need to balance the use case, and you need to thinking about the capacity of the use case. For example, if you have the project for 1 million people concurrent, something like that, you need to thinking the hardware and how to optimize the hardware and concurrent. And you need to think more about the application and the communication layer. For the AI infrastructure, it have many layer, the kernel layer, low layer level layer. That's why I told everyone you need to concern about the AI infrastructure, not just the AI application layer. Because if you have good infrastructure, you can scale and balance the electricity, balance the the computational resource, reduce the computational resource as well. That's why I think if you know how to optimize, if you know how to fine tuning, how to I think okay, it's better. Not just the make the AI application, not just make the chatbot. Okay. And I think the third one is about the centralized data center architecture, dominant standard AI training. Okay. Okay. I think it's okay. For the dominant standard AI training in the future, or we are moving toward the distributed edge computing to reduce latency. Sure. I think the in Thailand it have the many data center. It have many my experience is I developed the edge computing for the use case for the many project as well. For the small use case, edge computing is have many kind of model, right? The NVIDIA Jetson Nano or the NVIDIA Jetson Thor is good. And for the simple use case or not complex use case, but if you're thinking about the large use case, the hyperscale use case, you need to thinking about the data center for make for cluster the AI for cluster the computational resource. Yeah, for scaling something like that, for reduce the latency and reduce the networking latency as well. I think the most important, you need to know how to optimize the AI infrastructure and AI operation. I think it's most important. Okay. Okay, I think another question about the view the image of custom chip ASIC custom silicon from startup major cloud provider. Yeah. I think nowadays we have many kind of chip called ASIC or the FPGA. Yeah, many kind of chip from the syllabus as well, from the Grok as well. Many kind of chip. Yeah, but it's the large company, right? From the US, from the China, it's also the monopoly as well. But from the small country, right? Like Thailand or many countries. I think it is good if you know the AI infrastructure and how to optimize first. And another thing, because for the low layer, the hardware, the ASIC and the custom silicon is the foundation. Is foundation. You need to learn a lot of how to build them, how to develop them, and you need the company like the TSMC or Samsung for if you can design the chip and send it to them for develop my chip to the custom use case. It is later. From after you can design chip by yourself, you need to learning complex about the mathematics, learning about the algorithm, many kind of neural network. And after that, I think you can design and send to many kind of major of cloud provider, major of the chip company to develop your chip. Okay, and the next question is about the public data on internet begin for run out for training. Okay, I think okay. For the internet and training for the how crucial will the role of startup focusing on the synthetic data infrastructure and curation of high quality. I think it's important because nowadays many data it is the synthetic data. It's use the AI generation. It do many data is come from the AI generate, right? You need to make the evolve and benchmarking quality is quite important. If you make the new model, new training model, you need to make sure your benchmarking, make sure your evaluation is good and it better quality. Okay. Okay. I think that's all for the Ahmad question. I think I answered all the questions.
Okay.
I have a lot of detail.
Thank you.
Okay.
For the rest of the questions, please just ask one question, and Mr. Nathan and I will only answer one question since we have a tight amount of time. So for the next question, may I invite, wait, hold on. I invite Gede Paramaputra. You may ask your question. Please just ask one. Thank you.
Can anyone hear me?
Yes.
Yes, we can.
Okay. For Mr. Pranit Navi, sorry, my mispronunciation.
You can call me
I'm
John.
not Thai.
Okay.
Yeah. Okay. Can you explain why Python language that's practically slower than C++ language, yet it used more on machine learning fields than C++?
Okay. Yeah. Python, if you use Python for develop things, I think it's a bit lower, and a bit slower for the C++ because the architecture of the programming language. The C language is the low layer level and the Python is high layer level. That's why you can easier to write the program. Is same as the English language, right? Like Python, right? Same as. But for the C language, you need to make the decide the variable, the pointer, and the type of the parameter as well. It's quite complex, more than the Python, and it's low layer level. But nowadays many AI application, many AI framework use Python because we have the runtime that can convert the Python language to C language. That's why if you write the Python, use the framework like TensorFlow, PyTorch, or many framework, it's not executed by Python itself, but you can write by Python. But in the but after that, if you write the Python and execution, but it's transferred to the C kernel, C++ kernel to execution to your computer. That's why Python is high level and C low level. But nowadays, I think you can write the Python for AI application. I think it's good and easier. Yeah.
Yeah. Thank you.
Okay. Thank you.
Thank you for your question. And now I invite Audelia Nadeta. For your question, you may open your mic.
Thank you for giving me the opportunity to ask my question. And my question is, what makes AgiCaFed AI technologies different from other companies that provide similar AI and large language model solution? Thank you.
Sorry again. Again, please. Sorry.
Sorry if I say it too fast. My question is, what makes AgiCaFed AI technologies different from other companies
Okay.
that provide similar AI and large language model solution? Thank you.
Okay, sure. Thank you. Your question. My startup, it's called the AGI Cafe. I think of the different part is about my experience because I try to use my publication, my paper to the real product. It cannot copy because it's my published paper to the South Korea, to the Thailand, and it's hard to copy if you because it's complexity. It take a long time to build the published paper. And that is core knowledge about how can I optimize the sales by learning, how can I develop the AI technology from my company. And the second thing, I focus a lot of things, not just the software. I build the hardware also to connect it with drone. I build the physical AI also. I have many robots in my company. The small robot for the education. I have the humanoid robot for the warehouse. I follow up many technology, many of new age modern technology. That's why I think it's different from many company in the world or in Thailand because big enterprise, big company in Thailand moving too slow, moving the new technology too slow, because it's large company and yeah, many people, you need to sign the documentation first to buy something. You need to sign, you need to waiting for the high level to yeah sign to buy the something to develop something. You need to waiting for the large enterprise in Thailand. But for startup, it's flexible. It's faster. If you have the idea, if you have the yeah project, you can yeah go it. Let's do it. I think it's faster and yeah, I think it's different from many of the Thai enterprise. And for the startup, I think we use the my published paper and make and my company, we have the many researcher from the Tsinghua University from China and from the Tokyo University as well. It's many kind of the international researcher in my startup for make the yeah research, focus to the research and focus to product as well. Because the goal of my startup, I need to bring and transform research paper to the real product. That's why it's quite hard and quite complex to copy. That's all I think. Okay.
All right, that wraps up our Q&A session. Thank you for everyone for the great questions, and thank you for Mr. Nathanai for answering them clearly. It was an awesome discussion, and I hope it makes all of this feel much more relevant and understandable. Move on to the test your knowledge to games. Whether you've just been hearing or you've been listening, this time the questions refer to what Mr. Nathanai has carefully mapped out since way back in the beginning of our session. To play the game, you must click on the three dots on the right top corner of your screen and go to your accounts and enter your username so that we can identify which one has gotten the most points. To get your free account, press enter. Hold on. Excuse us for a minute. So what we've learned from Mr. Nathanai before, he's given us a lot of experience from driving cutting edge enterprise AI infrastructure as a CEO to educating thousands of developers and lecturing at top universities. His incredible journey proves that a deep passion for technology can open doors to global impact. And therefore, I invite everybody to test your knowledge by playing our quiz right here. You may scan the QR code. So first you click start. The first question is, why does the transformer use positional encoding? The options include to provide sequence order information that is not inherently supplied by self-attention, or to replace token embeddings with position-dependent vocabulary, to prevent attention scores from being normalized by softmax, or the final option, to determine which tokens should be classified as unknown. Pick your answers. Let's see who has gotten the most details. For the second question is, what is the main purpose of the attention mechanism in the transformer architecture? First option is to determine the fixed vocabulary size before the model begins training, or to encode the original sequence position so that the token order is preserved. And the third option is to convert contextual representations directly into vocabulary indices. And the final option is to dynamically weight contextual information from different input positions when forming representations. The encoder uses only positional information, while the decoder uses only token embeddings. The third option is the encoder and decoder uses identical attention patterns and different only in vocabulary size. The encoder processes input representations, while the decoder generates outputs using mass self-attention and encoder-decoder attention. You may pick your answers, and you know what's best. Fourth question is, why do NLP models need a tokenizer before text is given to the model? First option is because tokenization removes the need for embeddings and positional information. Second option is because tokenization guarantees that every sentence has the same number of tokens. Third option is because the raw text must be mapped into discrete units that can subsequently be represented numerically. Fourth option is because tokenizers perform the same prediction task as language models. Fifth question is, what is a major drawback of word-based tokenization when the vocabulary must cover a very large number of words? First option is it forces every word to be decomposed into individual characters, or it could be removes contextual relationships between neighboring words, or maybe it prevents frequent words from receiving individual representations, or finally can produce a very large vocabulary and struggle with unseen words. The sixth question is, what is a key advantage of character-based tokenization over word-based tokenization? Seventh question is, why is subword tokenization often considered a compromise between word-based and character-based tokenization? You may look up the options yourselves and pick which one is best. The tokenizer encoding process. What normally happens after text is split into tokens? Encoding mean in a tokenizer? Okay, for the participants, you may do the rest of the quiz yourselves. And this wraps up our final, and though it's not yet over, as I would like to hand over the stage back to our wonderful MCs. Thank you everyone for the participations in this session. Aku kok keluar? Hold on. Okay.
All right, before we end this conference today, I would like to remind all of us of the materials that we have learned today. So from the first session, we can see that language models are basically systems that learn from a huge amount of information and use that knowledge to predict what comes next. They become better with more data, better context, bigger models, and access to useful tools. We also learned that tokenization is an important part of how language models understand and process text. There are also some interesting lessons from high school science. To become a good scientist, we should be curious, try difficult things, experiment, read a lot, and not be afraid of failure. We should also increase our luck surface area by creating more opportunities for ourselves, being proactive, meeting new people, and being willing to help others. In the end, both language models and science remind us that learning is a continuous process. The more we explore, try new things, and stay open to opportunities, the more we can learn and grow.
To conclude everything that we've learned from Mr. Nathanai here, before I give the stage back to the MCs, I would like to conclude that the development of AI is not only about having advanced technology, but also about how we understand, adapt to, and apply it. AI should not be treated just as an additional feature, but as a foundation for building better systems and business processes. Since AI is developing very quickly, the ability to adapt and execute ideas efficiently is also becoming increasingly important. The material also highlights the importance of AI agents, which combine models, tools, skills, and context to perform tasks more independently. At the time, using AI effectively requires attention to security, privacy, efficiency, and scalability. Overall, the key message is that the biggest challenge in the AI era is not simply the technology, but human and organizational readiness. Therefore, We need to keep learning, adapting, and understanding AI so that we can use it responsibly, and effectively to create a real value. Now I would like to hand the stage back to our wonderful MCs.
Okay, thank you to our distinguished speakers, Mr. Marco Cognita and Mr. Nathanai Praninatawi, for the wealth of knowledge shared, and to our moderators, Azrael and Indra, for facilitating such a smooth and enriching discussion. May everything shared today be a source of inspiration and practical knowledge for all of us. We will now be taking over again as your MC.
With all due respect, our high school scientific conferences supervisor, Mr. Octaviano Hartanto, is currently busy and sadly he could not join us right now. And actually, Mr. Octa sent his best regard to Mr. Marco Cañeda and Mr. Nathanai Panitavi. Ladies and gentlemen, brilliant minds and future scientists, we've reached the closing moments of the High School Scientific Conference 2026. What an incredible day it has been. From groundbreaking ideas to inspiring discussions. Thank you for bringing your energy, curiosity, and creativity. This event wouldn't be the same without each and every one of you.
So, our presenters, thank you for your innovation, your courage, and your hard work. Before we officially end, we would like to express our appreciation to our keynote speakers, Mr. Marco Cognita and Mr. Nathanai Praninatavi.
Okay, before we officially close,
This certificate of appreciation is presented in recognition of the valuable knowledge and insight you've contributed today. Let's give a big round of applause.
Thank you.
okay, before we officially close, we will now proceed with our documentation session. We kindly ask all participants to turn on their cameras so we can capture this moment together. Everyone, please open your cameras, please. Because we're going to take a documentation of this very moment so we can take this moment forever. Okay, I still need more people to turn on their cameras, please. Every participant. Okay. Everyone, please turn on your cameras, please. Okay. I'm starting to see a lot of beautiful faces in here joining us at the moment. Okay. Can anyone, there's still some people that haven't turned on their cameras yet. Okay. Okay. Everyone looks perfect here. Looks like everyone's almost ready. So let's smile for the camera. I'm going to start the countdown to 1 and say cheese. 3, 2, 1. Say cheese. Okay. And we're done. Thank you all for participating in the documentation.
This concludes today's High School Scientific Conference. We hope the knowledge gained will continue to guide and inspire you in your academic personal journey. Let's carry forward the passion we've ignited here today. Stay curious, stay bold, and keep asking, what if?
On behalf of the entire committee, we sincerely apologize for any shortcomings and extend our heartfelt gratitude to everyone who made this event possible, from our mentors and speakers to the committee members working tirelessly behind the scenes. And to all participants, thank you for your enthusiasm and spirit. We hope to see you again in the next high school scientific conference. Take care, stay curious,
and
and
wassalamualaikum
wassalamualaikum
warahmatullahi
warahmatullahi wabarakatuh.
wabarakatuh.
Goodbye.
Goodbye, guys.